You know that feeling when you're building some furniture, you step back and realize you missed a critical step. Ugh. Well, that same sinking feeling can happen with databases. You design a table, data starts pouring in, and then it hits you. The design is just wrong. So what do? Today, we're going to look at the power tool that lets you remodel your database tables, even when they're live and kicking.
This right here, this is the exact scenario that can keep a developer up at night. Your app is live, data is flowing in, and bam! You realize your students table is missing a super important email column. You can't just tear it all down and start over, right? So what's the move? And that leads us right to what I call the set-in-stone problem. Look, when a table is brand new and empty, sure, you can just drop it and recreate it, easy peasy. But the second it has real data in it, or even worse, other tables depend on it, that blueprint suddenly feels like it's been carved in granite.
Yeah, trying to drop and recreate a live table, it's kind of like trying to swap out the foundation of a house while people are still living inside. You're just asking for trouble. You risk losing data forever. You could break all sorts of connections with other parts of your database. It's a path you absolutely want to avoid. So, we need a better, safer way.
And that better way has a name. It's a command that acts like your table's very own multi-tool, alter table. This thing is designed specifically to let you modify a table structure safely without having to nuke everything and start from scratch.
And just look at how much this one command can do. It's not a one-trick pony. We're talking adding or dropping columns, changing data types, even totally rewriting the rules, the constraints of the table itself. It is a complete toolkit for pretty much any structural change you can imagine. Okay, so it helps to know where alter table fits in. It's part of what we call DDL, or Data Definition Language. The easiest way to think about DDL commands, like create, alter, and drop, is to see them as the architectural blueprints. They don't touch the stuff inside the building. They just change the building structure itself.
All right, enough theory. Theory's great, but let's see this thing in action. We're going to start with the most common job you'll probably have, remodeling the columns. You know, the fundamental building blocks of any table.
Okay, let's go back to our problem, that missing email column. A simple alter table, add column command slots it right in. Boom. Our table goes from 2 columns to 3. But wait, that raises a pretty big question, doesn't it? What on earth goes into that new column for all the rows that were already there?
Well, here's the answer. By default, the database just fills that new column for all the old records with null. And null is just SQL's fancy way of saying there's no value here. But, a smarter move is often to specify your own default value. Maybe something like unknown@example.com, just so you don't have a bunch of empty data sitting around.
Okay, so what if you need to go the other way? Let's say adding that email column was actually a mistake, and now you need to get rid of it. The drop column command handles that, taking you from 3 columns back down to 2. But, and this is a big but, this operation comes with a very serious warning.
And you have got to pay attention to this because there is no undo button. This isn't like dragging a file to the recycling bin. When you drop a column, all the data in it is gone. For good. Permanently. And any constraints or rules that relied on that column, poof, they're gone too. It's an incredibly powerful command, for sure, but it can also be incredibly destructive. So you have to be careful.
So what if you don't want to add or remove a column, but just change the type of data it holds? Maybe you want to go from text to a number. For some really simple changes, the database is smart enough to figure it out. But for anything tricky, you have to give it a recipe. And that's exactly what the using clause is for. It's you giving the database precise step-by-step instructions on how to convert the old data into the new format.
Okay, let's talk about a much, much safer operation, just renaming a column. Say student name is just too abbreviated for your taste. Changing it to student_name is super quick and simple. The best part, it doesn't touch the underlying data at all. You're literally just changing the label on the front of the file cabinet drawer.
All right, so we've talked about the building blocks, the columns. But alter table goes deeper. It actually lets you rewrite the rules that govern your data. And this is where we get into things like constraints and default values. So let's imagine you want to make sure the stud name column can never be an empty string. You can add a check constraint to do exactly that, even after the table's been created. Before, pretty much any text was allowed. Now, after you add this rule, the database will reject any attempt to put an empty name in there. But what about all the names that are already in the table?
And here is the crucial detail, the gotcha.
The second you try to add that constraint, the database immediately scans every single existing row to make sure it follows the new rule. If even one student has an empty name, your whole alter table command will just fail. So the lesson is you have to clean up your data first before you can enforce a new rule on it.
We can also change a column's default behavior. Let's say you're tired of every new student having a null email. Well, you can just set a new default, something like no reply at school.edu. Seems simple enough, right? But just like before, this change comes with one really important catch.
So unlike adding a constraint, changing a default value is not retroactive. This is a super important distinction to remember. All those existing students who already have null for their email, they're going to stay null. This new default only, and I mean only, applies to new rows you insert into the table from this point forward.
And finally, for the grand finale, you can even rename the entire table itself. Maybe that abbreviation, stud.dtl, is just causing way too much confusion. Renaming it to student details makes everything so much clearer. And the best part? Just like renaming a column, this is another totally safe metadata-only operation. All your data, your indexes, your constraints, everything just moves right along with the new name.
So, what does all of this really show us? It shows that a database schema isn't some rigid, unchangeable blueprint that's set in stone. It's actually more like a living document. And with a tool like Alter Table, you have the power to adapt and evolve your database structure as your app's needs change over time.
Okay, to wrap this all up, here's a quick little glossary of the key commands we've just walked through. Seriously, this is a great one to screenshot if you want a handy cheat sheet for later.
And all of this leaves us with one final, pretty big question. Now that you know you have this incredible power to change almost anything later on, how should that affect the way you design your tables in the first place? Does it free you up to be more flexible, maybe a little looser at the start, or does it actually make getting it right from day one even more important? It's definitely something to think about. Thanks for joining me for this one.